Welcome to this explainer. We're embarking on a pretty incredible journey today. If you've ever looked at a super complex piece of software and just thought, how on earth did someone actually build that? Well, you are in exactly the right place. We're going to break down the Foundational Orientation for Computer Programming 1, which is all about an introduction to programming using C++. You can really consider this your ultimate starting line for building real, functional software. I'm absolutely thrilled to guide you through this material because it truly lays the groundwork for everything you'll do as a developer. All right, let's dive right into this.
Here is the map for our orientation today. We're going to cover the course overview, learning outcomes, our learning roadmap, grading and assessment, requirements and policies, and finally, you'll get to meet your instructor.
Section 1, Welcome to Programming 1, where absolutely no prerequisites are needed.
Let's quickly break down the logistics for your mission here. This is a 3.0 unit course. That's split into 2.0 units of lecture and lab, and 1.0 unit on the Learning Management System, or LMS. Now here's the best part. You do not need a background in coding, advanced computer science theory, or complex math to succeed here. You'll be dedicating about 3 hours a week to this, scheduled for Tuesdays on the LMS and Thursdays for your hands-on lab. The format is this really powerful blend of theoretical lectures, hands-on laboratory coding, and independent LMS work. This structure basically ensures you aren't just hearing about code, you're actually actively writing it every single week.
Section 2, Mastering Core C++ Skills. We'll be looking at 4 specific coding superpowers. First up, you're going to learn how to write and debug syntax-correct C++ programs. And importantly, we aren't messing around with outdated tech here. You'll be using modern C++17 and C++20 coding standards, so you're learning the industry standard for safe problem solving right from day one. You won't just copy and paste code. You're going to know how to build a program, compile it to see if the computer actually understands it, test it, and, crucially, fix it when it breaks. Debugging is literally half of a programmer's life, and you're going to learn how to handle those syntax errors with total confidence.
Second, you'll learn to control dynamic program flow. Because let's face it, programs aren't just straight lines, right? They have to actually make decisions. You're going to use conditionals, like if this then that statements, along with loops to handle different dynamic paths. This means your code will actually be able to respond intelligently to users and validate their input. That way, your program doesn't just crash if someone accidentally types a letter instead of a number.
Next is how you handle the actual information. You're going to master data collections, specifically using standard vectors, or std.vector in C++. Now, this is a massive step up from basic variables. You'll be able to store, manage, and process entire in-memory records of data. You can think of this as giving your program a dynamic memory bank to organize really large amounts of information efficiently.
And finally, we hit the ultimate programming power you'll unlock, applying object-oriented design. Instead of just writing a bunch of isolated lines of logic, you're going to learn how to model real-world entities using encapsulated C++ classes and objects. So if you're building a banking app, you literally create a bank account object. This is exactly how real commercial software is architected out in the wild, and you're going to get hands-on experience with it right here in your very first course.
Section 3, Your 18-week journey, covering 5 phases to object-oriented programming.
Let's walk through this timeline. Weeks 1 to 4, that's all about getting your footing. You're setting up your environment, learning basic syntax, and doing simple input and output. Once you're comfortable there, weeks 5 to 8 introduce control flow, those conditionals and loops we just talked about. By weeks 9 to 13, you level up to functions and data, breaking your code into modular, reusable blocks and working with arrays and vectors. Weeks 14 to 16 introduce advanced concepts like file input-output and classes. And finally, weeks 17 and 18 are fully dedicated to your capstone project and your final defense.
Now, inside that 18-week roadmap, there are 2 massive assessment milestones you'll want to circle on your calendar right now. Your midterm exam closes in week 8, covering all those early basic syntax and control flow topics. Then your final leg culminates in week 18, where both your final exam and your live project defense will close, covering functions, vectors, and of course, your object-oriented design. These are your big checkpoints to prove exactly what you've learned.
Section 4, Measuring your success through transparent grading.
Listen, a grading system isn't a threat. It's literally just a concrete metric of your growth. Notice the balance in the grading breakdown here. 30% of your grade comes from major examinations, and exactly 30% comes from laboratory exercises and programming activities. That is a perfect 30-30 split.
What this tells us is that your practical hands-on ability to write code matters just as much as your ability to take a written test. The rest of it? That's made up of 20% for quizzes and long exams, 10% for class standing like your attendance and participation, and 10% for your final project or case study. When you understand exactly how your success is calculated, you can focus your energy where it matters most, totally avoiding any surprises at the end of the term.
To make sure you're succeeding across all those percentages, your progress gets supported and checked in 5 distinct ways. First, there are formative assessments, so daily quizzes and seat work to quickly check if you grasped today's lecture. Then summative assessments, which are your big midterm and final exams. Third is performance-based evaluation, grading your lab exercises on correctness and your coding style. Fourth is the project-based assessment, where you actually do a live presentation. And fifth, peer and self-assessment through pair programming. You're basically being evaluated fairly and dynamically from every possible angle.
Section 5. Tools for the journey, requirements, and policies.
Your absolute core tool for this journey is a laptop equipped with a working C++ compiler. The source material explicitly lists G++, VS Code, or Dev C++ as your primary options. You absolutely must have this ready for both your lecture and lab sessions. You can't learn to program just by watching someone else do it. Your fingers need to be on the keys, interacting with your own compiler, dealing with your own real-time errors, and finally experiencing the thrill of a successful build.
Beyond the hardware, you've got 3 main keys to survival in this class. First up, on-time submissions. Deadlines matter out in the real world of software development, and they matter here for your labs. Second, active participation. You have to engage in the discussions and pair programming. Seriously, don't just hide in the back. And third, perhaps the most important one of all, integrity. The policy demands strict academic honesty with a zero-tolerance rule for plagiarized code. You have to write it yourself to actually understand it.
The good news? You won't be doing any of this alone. Your guide this term is instructor Freddie Rick Gerasano. He's here to mentor you from your very first frustrating syntax error all the way up to presenting your final, fully functioning object-oriented project. Having an experienced instructor to debug your early conceptual misunderstandings is an incredible resource, so make sure you use it.
Which brings us to the ultimate question. Are you ready to write your very first line of code? You've got the map, you know the tools, and you know exactly what superpowers await you at the end of these 18 weeks. Next session, bring your laptop, make sure your compiler is fired up, and most importantly, bring your curiosity. You're about to build your very first C++ program. What are you going to create when you finally understand how to speak the exact language of machines?